3. So this will be 27 by 3 and 1 by 3. So this is going to give you 26 by 3. So this was a pretty simple question. Let's try a slightly different one, a slightly more complicated one. This one, give this one a try. It shouldn't take very long though.
Ma'am, please scroll down. Scroll up.
It should be e to the power x square plus c.
What we did here, please.
Do you have a doubt in the previous question or this one that we'll be attempting now?
No, we discussed, right? This one.
This one?
Just a second. Yeah, it's fine now.
So for this one, let's do this one now. So this is just simple substitution method. You have to substitute x square equals to t or any other variable. So if your x square is t, then 2x, it will differentiate both these sides with respect to t. You'll have 2x here and dt by dx here, right? So simply you can just write 2x dx on this side and dt on that side. So that will give you 2x dx. Now you have this thing here, 2x dx, and you can replace 2x dx with dt. So this entire integral then becomes e to the power t, and then 2x dx is just dt for this thing. So in place of x square, we have t now, and in place of 2x dx, we have dt now. So this integration now becomes, this is a simple integration, which we all know. The integral of e to the power t is just e to the power t. And then you can have, so because everything was given in terms of x, so you need the answer in terms of x, right? This will be e to the power x square, and a constant is always there. So this should be the answer. While integrating, a constant is always involved, so this should be the answer. Okay, then coming to the next question. This is the next question. Give this one a try.
x sin x plus cos x plus c.
So let's do this one here. You have x cos x, you have to use integration by parts. So integration by parts, the formula for that is, if you have ux dx dx, this gives you just u, then integral of v with respect to x, then integral derivative of u with respect to x, and integral of v with respect to x, and this entire thing with respect to x. Right? This is it. So let's have this as, and the order for u is this. You have to use this thing highlight. So because so u function has to be considered this one. This is a trigonometric function, and this is an arithmetic function. So you should be considering x as u. And you can also see that this, if you derivate x with respect to x, you just get 1. So okay, you just simply follow this lineate rule for u function for choosing u. So this should be your u function. This should be v. So this is going to give you so integration of x cos x, then will be x as it is, integration of cos x, then the derivative of x, so it's dx by dx, and then integral of cos x with respect to x, and then dx, right? And this will be x sin x minus, we'll have 1 here, and then integration of cos x with respect to x, so it will be sin x. So time is going to give you x sin x is already here, and then the integration of this thing is minus of cos x, right? So it will be plus cos x. And the constant is always included at the end. So this should be the answer, x sin x plus cos x plus c. So it's, yeah, this should be the right answer. Then this has been tried.
It should be 0, ma'am.
Yes.
We can split it into two parts, like minus pi to 0, then 0 to pi.
Yeah,
And
right.
it's
You can do
an
that too.
odd
Yeah.
function, so
You can do it this way, or you can just simply integrate it. So one way is to integrate the usual way that you do, integrate and then use the limits. And the other one is using the odd even functions thing. So if you have something like, if you have a function where your f of x is equals to f of minus x, if this thing is equals to f of x with a negative sign, then this means if you have the integral of such function from, let's say, minus 1 to 1, you have this function, then you can write this as minus 1 to 0 fx, not writing dx here. So this thing. So this function is just going to be 0 to 1 fx, and this is going to be, so you can, instead of this, you can just write this as 0 to 1 f of minus x, right? And this is just minus f of x. So this is integration of minus fx from 0 to 1. This is integration 1. So you have, basically it's just this quantity as negative first, and this quantity as positive. So this gets cancelled.
ma'am, your
So
voice is
this will just be
breaking.
0.
Minus sin x would become like x
If
pi
you have a
minus
function,
x.
okay, we'll have a look at this function later. If this function is a function like this, we'll come to that one later. But before that, if you have a function where if you substitute x in place of minus x, then if it's equal to this, for example, let's say you have x cubed. Now, if your function is x cubed, if I replace x with a minus x, I'll have minus x cubed, which is equals to this thing, minus x cubed, right? So this function is a function of this form, right? Where if you replace x with a negative x, you will get minus of fx. This is minus, this is fx, and this is.
Ma'am, your voice is breaking.
Okay, is it better now?
No, ma'am, still breaking. I mean, sometimes it happens in between.
Okay. So try to be more clear while that I can do now. Don't have it to be. Is it still
Ma'am, again, it's breaking.
okay?
Basically, the fx is odd here, so it will result to 0 by the property.
Okay. If it breaks too much later, we'll try to figure something out. But now I can't do anything. It's a connectivity issue on my end, I guess.
It's okay, ma'am. You can continue with it.
Is it fine now?
Yes, ma'am. It's better now.
Okay. So what we were discussing here is if you have a function of this form, if you have a function, and example of these functions are, one is obviously sin x. Sin x is a function. Examples of such functions. Examples where your f of x, f of minus x is the same as minus of fx. So such examples are sin x, then you have x, then you have x cubed, or in fact, any power, any odd power of x to the power 2n plus 1. Then do we have more functions like, we have a lot of functions like that. I can't think of more
And
functions
x cos x also.
right now. No, cos x is not one, not such function,
X
not one
cos
such
x.
function. Yeah, x cos x works, right? So x cos x is also one such function where you have minus x. So if you replace it, this is your fx, then your f of minus x will be minus x and cos of minus x, and cos of minus x is just cos x, so it will be minus x cos x, which is the same as minus of fx. So this is also one such function, x cos x. Then you can have, in similar way, in this manner, you can have x square sin x too. That also works. You can have sin x cos x too. That also works. So these are the functions where such things, where this condition holds. So if you have a function like that, and in fact, the question that you have, your x plus sine pi x function, if you have something like, if I replace x with a minus x, I'll have minus x plus sine of pi and minus x here. So it will just be minus of pi x. If I replace x with a minus x, this is what I'm going to get, right? If this is fx, then your f of minus x is this. So your f of minus x is actually minus x, or you'll have minus of x minus sine pi x, and this is just minus x plus sine pi x. And this entire thing is just fx, right? So this is fx minus of fx. So your f of minus x is minus of fx, and we've just checked, just seen this thing here, that if your f of minus x is minus f of x, that means in this rule is in general, it's not from -1 to 1, it's from, if you have a function of this form. So if you have to generalize it, you can have minus a here and a here, right? Obviously you'll have to take a greater than 0, because if your a is less than 0, then I can't write 3 and minus 3, I can't write the limits as this, right? So your a is greater than 0, that's understood. If that happens, then the integration of fx, provided your fx is one such function, is of this form, f of minus x is the same as minus fx. Then, and these are also called odd functions, because it's, you can remember it from here. The odd powers are of this form, so you can, these are also called odd functions. So if your a is greater than 0, you can break this thing from minus a to minus a to 0, and then 0 to a. and this thing from, so this then becomes, if I'll replace C, this is what we're doing here is, what we've done from this step to this step is, instead of X, I have substituted X minus T in place of X. So if I do this thing, I'll have X is equals to minus T, and then my dx will be equal to minus of dt, right? So here I'll have minus t minus dt from, where have we done this thing? From minus a to 0, right? Just give me a minute. Yeah. So if you, then you'll have this thing, because they've replaced x with the variable minus t. So this is what's going to change. And because your dx is equals to minus dt, so you're going to have a negative sign here. Right? We have replaced minus t, x with minus t. So dx will be minus dt, and this limit is also going to change then. When you do these things. So if your x is, I'm explaining why this is just a direct formula. If you replace, this is a direct thing that you should know, but I'm just explaining how do you get it. If you have fx from minus a to 0, you can simply write f of minus x from 0 to a. This is an identity. But if you don't want to use this identity directly and you want to know how we get to this identity, then I'm explaining that part here. If your x is minus t, you will have dx is equals to minus dt, and then you'll have to change the limits as well, right? So for x is equals to minus a, when x is minus a, because you've replaced x with minus t, that means your minus t is minus a, and your t is just a, right? So you'll have t is equals to a, and when your x is equals to 0, your t will be 0, right? So this limit will be from 0 to a. That's how things change here. So and then you can just, instead of, now we know that this function is an odd function, so we can replace this thing with a minus sign here. So you have, wait, we have one extra negative here, minus a to 0. Just 1 second. Using the substitution method here, right? So this will be, instead of x, we have substituted minus t. So we'll have f of minus t here. Then instead of dx, we'll have minus of dt. That will give me minus here and a dt here. And from here you'll have, okay, yeah, you have the limits as, when you have x is equals to minus a here, you'll have t is equals to a. So this is a. And when you have x is equals to 0 here, you have t equals to 0 here. So this will be it. And now if you change the things here, this is an identity now, right? That if you have a to 0 fx dx, and if you change the limits here from 0 to a fx dx, then a negative sign gets introduced here, right? This is an identity. So we'll make use of this identity here, which gives us instead of, now if I interchange these two, if I do 0 here, A here, then a negative sign gets introduced. That means I'll have one more negative here. This negative is going to become positive. And here you will have this thing. That means you will have minus x from 0 to A. And we know that we can take this one out, right? This is also A, this is also A. So we can take this negative sign out because it's an odd function. So you'll have 0 to A, f of x with a negative sign here, plus 0 to A, f of x dx. So this will just be 0. So we've done every reason, every reason why what we're doing, why we are doing, and how do we get these identities. Or if you want to skip this substitution part, what you can do is as we did previously, you can just replace. This is also one of the identities. If you have f of minus x here, from let's say 0 or from anything to anything, let's say from A to B, then this can simply be written as f of x from B to A. That's fine. You can do this thing. Instead of doing all the substituting x is equals to minus t and all of that, you can just simply do this thing. Use this identity. And the alternate way is obviously the usual way we do integration and all. So if you're not comfortable using this method, you can just simply integrate this function, which isn't very difficult either. But there's no point, right? If you'll integrate, do you want me to do it the other way as well? The usual way, this one.
No, ma'am.
Okay. That's a simple integration. Integration of sine pi x and integration of x. This will be x squared by 2. Then this will be cos pi x with a negative sign. And then a pi here. That's it. And then you have to apply the limits from minus pi to pi. That's what you have to do if you're doing it the usual way.
Ma'am, the previous thing that you said, the last thing that you said of integration 0 to A and how we can change the limits by applying minus sign. Yeah, is that only applicable when we have 0 and a constant, or it's applicable for any limits?
This is applicable. This one
Yes, that one.
you're talking about, yeah, you'll have to have 0, right? Because what's happening here is, let's say you have a limit, you have limits from 1 to 2. And if you have fx, then how do you introduce the negative numbers here? The idea is that if you have 0 here, then some part of it is here on this side, on positive side, and some part of it is on the negative side. So they get cancelled. That's the idea. But if you don't have the negative side at all, if you have everything on the positive side from 1 to 2, or if you have everything on the negative side from minus 2 to let's say minus 3, then they'll have the same sign, right? The sign
Yes.
doesn't change, so nothing gets cancelled then. You'll have to
Okay.
have 0 in middle. And in fact, this is only applicable. So your identity in short becomes, a short identity will be if you have minus a to a f of x dx, then this becomes, if your function is, this becomes 0 if f is odd. That means your f of minus x is the same as f of
Okay.
minus fx. And this becomes 2 times integration of fx from 0 to a if f of minus x is the same as fx. Those are even functions like cos x, like x squared, right? So if you have a function like that, then this is what your integration becomes. Integrate
Okay.
it from 0 to a and then multiply it with 2. So you will get the answer. This is
Okay,
the
ma'am.
identity in short.
Okay.
Okay. Let's do this question. The question's visible, right? Give this one a try.
Ma'am, it should be 5/2 minus e to the power -1, and we can take the absolute value of this.
Let's see. Let's see what's the answer. So you have been given two functions. One is fx e to the power minus x and gx as 1 by x plus 2. Now my problem is, let's say you have a curve. This is your curve and this is your curve, let's say. And you have to find the area between these two curves. Let's say this is just, let's say this is the curve AX and this is the curve BX. And you have to find the area enclosed between these two curves from, let's say, A to B, from here to here. That means from here to here. That means you have to find this area, right? So how are we going to do this? What we do here is, we know that if I'll do this thing, integration of AX from A to B, this is going to give me this area. This quantity is going to give me this area. This is AX, so it's going to give me this entire area, right? And then if I have this thing, integration of BX curve from A to B, let's call this the green one. This is going to give me this area. The area under B curve, right? So it's going to give me this area. And if I subtract this, so if I subtract this green area from the blue area, I'm going to get the required area, which is this one, right? The area between these two curves is the red one. And to get the red one, I'll have to subtract the blue area. From the blue area, I'll have to subtract the green area. That means from this one, I'll have to subtract this one. But what's crucial here is you should know which curve is above and which curve is below, right? So if you have, yeah, you can take the mod, that also works. So to avoid trying to find out, one way is to actually figure out which curve is above and which curve is below. That's one way. So if I already know that AX between A and B, AX is above and BX is below. But after B, after this point, if you see, right, the interval also, that also matters. After in this interval, your AX is above BX, right? Sorry, your BX is above, this is BX curve, this is above AX. So interval also matters. So one way is to do AX, if you already know that in this given interval, where you have to find the area between these two curves, if you have to find the area between these two curves in the interval A to B, and you already know that AX is greater than BX in this interval from A to B, AX is greater than BX. That means AX is lying above BX, then you can simply do AX minus BX and you don't have to worry about the signs, right? But if instead I'll do BX minus AX in this particular interval, then I'll get the negative of what's required. So a negative sign will bother me. To avoid that negative side, let's say you do not know which curve lies above and which curve lies below. There will be cases when you wouldn't be able to figure out which curves lying above and which curves lying below. So in that case, you can simply take AX minus BX, take the integral, and then just take the mod, right? So if AX were actually lying above BX, then this entire quantity will be positive. Mod of this quantity will again be positive. But if that's not true, if AX is below BX, then this area will be negative and the mod will again give you something positive, which is required, right? If you have to find the area between two things, area is always positive, right? So you want the quantity to be positive. So to make sure your quantity is positive, you can simply put a mod sign, and you don't need the mod sign, by the way, if you already know which curve lies above and which curve lies below. So for your simplicity, because we do not actually need to figure out which curve lies above, if you want to, we can tell that too. Actually, we'll do that too. But let's just do it the simple way first, right? What's simple for you? So you have a curve fx, you have a curve gx. And what you can simply do is just do fx minus gx or gx minus fx, whichever you like. Just do this thing. and integrate it from 0 to 1. That's where you have to find the area, right? So from 0 to 1, do this thing and then put a mod here. That's it. So let's first find out the integral, where fx is e to the power minus x, gx is 1 by x plus 2. So take this integral from 0 to 1. So this integral will be e to the power minus x and a negative sign here. And then this thing will be minus of natural log of x plus 2, right? This will be it. And the limits are from 0 to 1. So this is going to give you, if I'll put 1 here, I'll have e to the
Can
power
we
minus
take
1.
like
Yeah.
x plus 2 as t? Then we get dx is equal to dt and we can do that dx by t. Then we get direct ln t. And we can convert the
Are you talking about this one? Yeah, you can do it using substitution, but this one's a little easy to use substitution, right? You don't have to use that. If you just have to find x plus 2 integral, then it's just instead of 1 by x, it's just x plus 2, a constant added. That changes nothing. So it's simply just natural log of x plus 2. But if
hello. Hello.
substitute this as t, then can you hear me?
Yes, yes.
Am I audible? Okay. Then you'll have dx is equals to dt. So you'll replace dx with dt. And eventually you'll get the same thing, right? Your t is x plus 2, dx is dt. So you'll have 1 by t dt, which will be the same as natural log of t. And this is the same as natural log of x plus 2. So it
But you
is
can
going to give
convert
you
the
the same
limit
thing.
also. The limit will become 2 to 3. That
Okay,
way.
if you will change, let's say you have 0 to, what do we have here? You have 0 to 1 here, then you
0
will
to
change
1.
the limits here accordingly. You change the limits here, and then you will have something in, then you will have this here, 0 to 1, and you're changing this entire thing. That's up to you. If you want to change the limits here, change the limits here, and end the question here. If you don't want to change the limits, you can first integrate it with respect to t, and then finally you can have your answer in terms of x, and you can use the same limits here from 0 to 1, right? Is that okay? So we have done
Yeah.
this one. We're skipping this entire t part because it's, I mean, using substitution in such small problems is not very advised, but not something I'd advise. You don't need substitution here. Substitution is for like bigger problems where there's no alternate, where you don't know things very clearly. So this will be, so if I substitute 1 here, I'll have minus e to the power minus 1. Let's take minus common. This will be e to the power minus 1, and then minus of e to the power 0. So this will be 1. And then here you will have, let's take the negative common from this entire thing because both of these terms have negative. Then this will be natural log of 1, so natural log of 3 minus natural log of 2. So this will become minus 1 by e plus 1. You can have a negative here, natural log of 3 by 2, or you can take the negative here inside and then you'll have natural log of 2 by 3. So let's see what our options is. Do we have options here? No. Okay. And you don't even need options here. So this, yeah, so this is your answer. And you can use your calculator to find out what this value is. If it's a essay type question, then you will have to write the numerical value of your answer. So you can find the value of this, right, on your calculator. Or if it's an MSQ or MCQ, then you will see options there. Your option could be 1 minus 1 by E minus natural log of 3 by 2, or it could also be 1 minus 1 by E plus natural log of 2 by 3. So you will have to simplify things according to that. That's it. For now, this answer works fine.
Ma'am, can you scroll up a little bit to that diagram, that graph?
And just 1 second, just 1 second. So you will have, and we talked about the mod sign here, right? So you can use the mod here if this quantity is already positive. So for that, let's say you have been given options. It happens a lot of times. This is a difficult quantity to actually know if it's positive or negative, right? You can't just look at this quantity and tell if it's positive and negative. What we planned to do was, if our answer was positive, we leave it there. If it was, let's say, if our answer was 2, then we'll leave it there. If it was minus 2, then we'll make it to 2. And that will be the correct answer, right? Because we're trying to find the area, and area is never negative. But now we don't know if this quantity is positive or negative. So what we do is, we have, if you have been given things in options, let's say you've been given things in options, and this is one of the options, and the negative of this is also one of the options. Let's say the other option is minus 1 plus 1 by E plus natural log of 3 by 2. This is exactly the negative of this, right? If these are two options, then you will have to pick one of these. One way is to find out the answer in your calculator, which one is positive, and whichever is positive will be the correct answer. The other way would be, you have fx here. So, and you have to find the area from 0 to 1. So this is 0, this is 1. Your f0 is, what's f0? If I do 0 here, I'll have 1, right? So f0 is 1, and your g0 is half. That means at this point, at 0 point, f lies above g, right? So if that means f lies here and g lies somewhat here. You don't even need to know how exactly how does it look like. You just need to know which graph is above at the point 0 and which graph is below, right? So at 0, your f lies above and g lies below at this point, at x equals to 0. And at 1, f of 1 is, if I'll have 1 here, I'll have e to the power minus 1, which is 1 by e. And if I'll have 1 here, g of 1 is 1 by 3. Which one do you think is greater? Your e is 2.7. Your 3, and you have 3 here. So 1 by 2.7 basically, and 1 by 3. So 3 is greater than 2.7, and so that means this is greater than this. That means f1. So what do we have from here? f0 is greater than g0, and f1 is also greater than g1. Now that means that f remains above g throughout this thing. That's not the exact graph of f and g. This is just for you people to understand. And that means you can simply assume that f of x minus g of x, and then integral from 0 to 1 is going to give you the right answer. And if you actually want to see how the graph looks like, because these are pretty simple graphs, you should know it. So your e to the power minus x, the graph of e to the power minus x looks like this. It looks like this. If someone has a doubt in how does the graph of e to the power, if they know how the graph of e to the power x looks like, then you should know how e to the power minus x looks like graphically. If you don't know, we can explain that too. If someone has a doubt in that, we can explain that. And 1 by x, we know the graph of 1 by x looks like this, right? So your 1 by x looks like this. and we've already done this thing. This is just like shifting origins. If you have fx and your fx looks like this, and let's say this, if your fx looks like this, then f of x plus 2. So what has happened is x got shifted 2 units, or if let's say you have if you have x minus 2, that means x got shifted 2 units to the right side. That means now you'll have, originally this was at 0, 0. Now you have the same thing at y is equals to 0 and x is equals to 2. This will be this. You'll have the same thing at the point. Here you had this at 0, 0. Now you'll have the same thing at 2, 0. And your graph will look exactly. That means this entire graph gets shifted to this point here, like this. Similarly, if you have, we've discussed this shifting of origin things a lot of times before, right? Does anyone have a doubt in how we shift the origins? So if you have 1 x plus 2, that means x minus of minus 2, that means your graph should look like. So 1 by x minus 0 looks like this. This. So 1 by x minus minus of 2 should look like this. This is x is equals to minus 2 and your graph is going to look like this. And this. Because we're doing the integration from 0 to 1. So we don't need this part. You can forget this one. So this is your graph for 1 by x plus 2. And the graph for e to the power minus x, we already discussed, it looks like e to the power x looks like this. And e to the power minus x looks like this. So this is going to look like this. You just need to know which one lies above and which one lies below. And which we have figured out using this thing. Where have we done that thing? This thing. F at 0, g at 0, and f at 1 and g at 1. And we have seen that f of 0 and f of 1 both are greater than g of 0 and g of 1 respectively. That means your f lies above g. And your f was e to the power minus x, right? So e to the power minus x lies above 1 by x plus 2 between 0 and 1. Is this fine to all? If anyone has a doubt in this graphing thing or anywhere in this question, you can ask.
So the final
Ma'am.
answer will come as 0.45.
We don't have the final answer. I have the answer as this only, as what we've solved. You guys do have calculator in exams, right? You can use those calculators there. That's not an issue.
Ma'am, can you go to
Also-
the graph part?
Also, if I may ask, like
Yeah.
if we have ln3 minus ln2, so we can also compute ln3 separately and ln2 separately, and then we can subtract that to find the value.
You can do that, but why do you want to do that? When you can simply do this thing, why do you want to make it complicated and calculate this thing? It's just going to take more time. That's it.
Sometimes they give the NAT type question, no?
Sorry, what?
NAT type question.
Yeah, for that only I said, if you have an NAT type question where you have to write the exact answer in decimals and all, then you can just simply find natural log of 3 by 2 instead of finding natural log of 3 minus natural log of 2 on the calculator, right? You can do whatever, you can use the calculator whatever way you want, whatever suits you. That's fine. Does anyone have a doubt in this question? Any other doubt in this one?
Ma'am, can you just go to that graph part? Not this one, just a little left.
This one?
Not here, ma'am. Just below the question. Initially, you draw the graph, right?
This one?
Yes, ma'am, this one, yeah. So, sometimes both of the function may lie below the x-axis. I mean, it may lie in the negative y-axis, right? In that case,
Yeah.
we'll get negative area. So if we take the absolute value of that,
No,
then
you won't get negative. Area is actually never negative. If you've been asked to find the area, these are two different things. Fx minus integral is a different thing. Area is different, right? Integrals can be negative. Your area is never negative. So if you have something, let's say you have this thing and you have to find this area, let's say, then what you do is you take this curve. Okay, if you'll have this curve, if you'll find the area of, if you'll take the, let's say this is f and this is g. If you'll have the integral of f, you'll have something negative. That means you have this area, but in negative, right?
yes, ma'am.
And the same happens with the g curve. So how do you fix this thing? We know that we've gotten this area as negative and this area is negative as well. So one way to do it is just simply take g minus f. So what is it going to give you? It's going to give you this exact area that you require, but in negative, right?
Yes, ma'am.
So just take, and then you have to do the same thing. Because if you know, if this is a number that you can find out, unlike this one. Here we had some complicated stuff which we couldn't calculate if it's a, and you still can find this out using your calculator. If this, you don't have to go through this entire positive, negative nonsense. You can just simply find out the value of this using your calculator. If this is positive, you're fine. If this is negative, just change the sign there. That's it. So if
Okay.
you have this as positive, you're good to go. That's your answer. If this is negative, then you, and in this case, in this particular case that you're talking about, this is going to be negative. We all know, right?
Yes, ma'am.
So you'll have to change the sign there. That's it.
Okay, okay. So maybe in the concept of area under the curve, there we can get some negative area, right? Let's say we are considering the area between -1 to 0 of the graph x cube. In that case, we'll be getting negative area.
Your x cube looks like that. You're talking about 0 to
-1 to
-1,
0.
right? That's what I
Yes.
said when you take the integral of functions, right? Let's say
Um,
I have fx and I integrate this. This integration can be negative. Now,
yes,
what does
ma'am.
that mean? That means, but your area cannot be negative, right? If we look
Area
at
will
area,
not be
area is
negative.
never negative. So this integral is, if you get something negative, that means, like in x cube case, you're going to get the area from here to here negative because it's lying on the negative side, on the negative y-axis. So you'll get something negative. You'll have to change the sign. If you're being asked the area, let's say this entire area is -2. Then if you're asked the area, you have to write 2. If you've been asked the integral, then it's -2.
Okay, okay, okay. Okay, ma'am. Just before this question, we had a question like that, right? In that odd function. So
This was not about area.
it was about integral only.
Yeah.
Okay,
This was simply about finding the integration.
okay, 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 ma'am.
Okay. If it were really about, then you can't actually, do we need to discuss this thing? If you have to find the area of x, let's say x is also an odd function, it looks like this, right? So if you've been asked to find the area from here to here, the integral from here to here, if it's 1 and -1, the integral gets cancelled because this is positive, this is negative. But if you've been
Okay.
asked to find the area, just find the area of this, and because we know that
Then multiply by
both of
2.
these, yeah, just multiply it with
Okay.
2. The same that we do with
Okay.
even functions. Do the same here. Okay. Then moving to the next. Does anyone have any further doubts in this question? Okay. And this is the next question from graph theory. You have to tell which of these graphs are trees. Give it some time and
Option D is the tree.
other options are also trees here. Just
Option B.
check all of them. Okay, let's do them one by one here.
Option
Your
A is
first,
a tree.
you have this thing. It might look like they're crossing each other, but if you will have this as this, You can have this as this, right? You can have this point here. You can draw this one as simply this. So it's not, it looks like it's crossing, they're crossing each other and they're intersecting somewhere, but it's simply this graph. And this graph is a tree, right? Tree is simply, if you have forgotten the definition of tree, it's simply minimally connected graphs. So every vertex should be connected to other vertices. That means vertices should be connected with each other and it should be minimally connected. This is not a minimally connected graph if I join these two. Minimally connected means if I remove one more edge from here, the graph should not be connected. Like in this case, if I remove this edge, now it's not connected. That's your minimally connected graph. So this is minimally connected. So this is a tree. Then coming to the second option.
This is also a tree.
Let's see. This is, let's have this point there. We're having, let's mark these ones, A, B, C, D, E, F. So here you will have A, F here, then D here, then you will have B here, E here, and C here, right? So this is a connected graph. This graph is simply this. And it is minimally connected, so it's a tree. We can't remove any edge further. That would result in something in a graph that's not a tree.
Can
So
you
we
show it?
show what? Show this thing. We have redrawn this one. That's it.
Okay.
So this is a tree as well. Then coming to this next one, let's call this again as A, B, C, and D.
It's
E,
not
F.
a tree because it's not connected.
Okay, let's see. Yeah, if you draw this, you will have C is as this. If you have A, you have A connected to E, then E connected to C. So it's simply this AEC, and then these ones, AEC are in a line and DBF are in a line. D, B, and F. So this graph is simply this. And this is not connected. So not a tree. So this option is incorrect. Then coming to the D one, you don't have to redraw this one. This is pretty clear. We don't need to redraw this one because we can see that all of the vertices they're connected, and then you can't remove any edge. Any edge if you remove, this will result in a graph that's not connected. So this has to be a tree. Then coming to this E1, we need to redraw this one. A, B, C, D, E, F. Draw it here.
Ma'am, BD
This
EC
is
is a cycle, so from there we can say that it's not a tree.
okay. Yeah, we can do that too. Or let me just draw this graph clearly here. So A is, yeah, if you already see a cycle, then you don't need to draw this one. We have a cycle here. This, I'm marking the cycle in green. So this is the cycle. A, B, then B to C, then C to E, and then E to D. So this is a cycle. That's why this isn't a tree. For tree, what you need is it should be connected and it should be minimally connected. So whenever you see a tree, whenever you see a cycle, let's say you have this thing. Whenever you see a cycle somewhere, that means it cannot, if you have a cycle in your graph, that graph cannot be a tree, right? Trees, trees never have cycles. And we've discussed this thing already, that trees, we never see cycles in a tree. To see cycles in a graph, that means that's not a tree, like this one. So because this has a cycle here, it cannot be a tree, because tree means minimally connected graph. This is obviously connected. The problem is it's not minimally connected. Every graph with a cycle is never minimally connected. If you remove this edge, let's say you have these three edges. If I remove this edge, it's still connected. That means it's not minimally connected. Or in simple words, if you look here, you don't even have to get into the cycles thing. If I'll remove this edge, if I'll remove this particular edge, it's still connected, right? This
Yes.
entire graph is still connected. That means this entire thing is not minimally connected. That's the problem. That's why this is not a tree. Then coming to this one, we can draw this as, let's draw F here. Let's call this A, B, C, D, E. So this will be A connected to, they're connected in that order, right? So this is A, B, C, D, E. And then D is connected to E and C. It's connected to E, it's connected to C.
One more
C,
vertex
D.
you have not
One
named.
second. Yeah.
Vertex.
This
Two
one.
vertices you have not named, and the upper one.
A, B, C, D, E are in a line in a row. So we have them here. And then D is connected to G, this one. And A is connected to F. And D is connected to some G. So this looks like a minimally connected graph to me, unless we miss something from here. This is the exact same thing as this, right? Yeah. They're same. So that means this is, firstly, this is connected. That's the first thing you have to check. And second thing you have to check whether removing one of these edges will result in a connected graph or not. If it does not, if you remove any of the edge, this one, this one, this one, or this one, any one, and it's not a connected graph anymore, then it's a tree. Otherwise, it's not a tree, right? It should be minimally connected. So if I remove any of the edges from here, it won't be connected anymore. So that means this is a tree. That means this is also correct. So these 4 of them are trees, 2 of them are not. Does anyone have a doubt in this one? Can we move to the next one? So this is clear.
Yes, ma'am.
Okay. Give this question a try.
Ma'am, the third option, m minus n plus 1.
Okay, let's see.
And it should be given that like m should be greater than n minus 1, right?
Let's see what should be given. We'll come to that. Let's just give this question a read. It says, how many edges must be removed from a connected graph? So you have been given a graph with number of vertices is equals to n and number of edges equals to m. You have n number of edges, n number of vertices, and you've been asked to produce a spanning tree. So for you to have a tree, and you've been asked how many, let's say you have to remove t, you've been asked how many edges should be removed, right? So let's say t needs to be removed. T edges or t number of edges we're removing.
Can we say that m should be equal to n minus 1?
We'll see that. Just give me 1 minute.
Because there would be n minus 1 edges.
Just give me a second and I'll be back. Just 1 minute. We're discussing this thing. Let's say we have the number of edges is n. Sorry, the number of vertices is n, number of edges is m, and then we have to find the number of edges to be removed. And why are we removing the number of edges? We want a spanning tree, right? So from a connected graph. So if you have a spanning tree, we know, let's say you have n vertices. Let's say you have 3 vertices. And if you want or let's say 4, and if you want a spanning tree, then the number of edges there would be n minus 1, right? So if n vertices are there, then your number of edges for minimum number of edges, or actually number of edges in your tree, or a spanning tree. Spanning tree means a tree that covers, now this is also a tree, right? This is also a tree, but it's not a spanning tree because it's leaving this vertex. So for that, for a spanning tree, you will need n minus 1 edges. So if you have n number of vertices, like we have 4 vertices here, the edges in your spanning tree will be n minus 1, and we have exactly 3 here. This is the spanning tree, and it has the number of vertices is 4, number of edges. You can do it with 5 vertices too. If you have 5 vertices, then you can also see this thing. So there are 5 vertices now, and the number of edges would be just this. So this will be 1, 2, 3, 4. No matter how you make the spanning tree, or if I remove this one, then I'll have to draw this edge, right? Then also you have 1, 2, 3, 4, 4 edges. So with 5 vertices, you'll have 4 edges. With 10 vertices, you'll have 9 edges for your spanning tree. So if there are n number of vertices in your graph, then in the spanning tree for that graph, you'll have n minus 1 number of edges, right? So your number of edges that you require are n minus 1. And how many edges do I actually have? I have m number of edges, but I only want n minus 1 edges, right? And that's what you've been asked. How many edges should I subtract so that I have exactly n minus 1 number of edges, right? So I'll have to subtract, let's say I have to subtract t from here. Then m minus t should be equal to n minus 1. Now you can say, because t is a variable that we have chosen, so there are no conditions on t. Do we have conditions on m and n? So let's see, let's say you have m. From here you get m. If we first, we have to find t here, but if we first find m, you will have n minus or n plus t minus 1. So obviously you'd want that this quantity should be positive. So you'd want n plus t should be greater than 1 at least. Greater than or equals to Yeah, greater than 1. So, okay, we'll come to the constraints later. Let's first see what value of t are we going to get from here. So t you should get as m minus n plus 1. So these are the required number of edges that you need to remove. Now let's come to the doubts that some people had.
Ma'am, actually, like initially, I thought that m should be greater than n minus 1. But here in the question, it is given that it is a connected graph. So if it is connected, then m should be like greater than or equal to n minus 1. Otherwise, it won't be connected.
Yeah,
So,
if you have n number of vertices and you have to reach to n number of edges and you have to reach to n minus 1 edges, then obviously by reducing number of edges, then m has to be greater than equals to n minus 1, right? It's like
mhm.
that's obvious.
Yes, ma'am.
Although it should have been mentioned there that your n should be greater than equals to n minus 1. But
Yes.
then it makes the question pretty obvious. The options it makes very simple. So it gives you sort of a hint if this is given in the question
Yes,
that
ma'am.
this
Okay.
should be the answer. It's like simply saying your this should be greater than 0. So maybe that's why it's not given in the question.
Mhm. Yes, ma'am.
Okay, let's do this one. Give this one a try.
Ma'am, option 4, option D.
Okay, let's first draw the suggestion here would be first try to draw the BFS tree for this thing because you're performing BFS here. So you should draw the tree first, right? So let's start with, and you're starting your search from A. That means A is the first vertex. Then directly connect. What do we do in BFS? We see the ones that directly have an edge with the starting vertex. So A has a direct edge with B and E.
Yes, ma'am.
So
Option
on,
A is correct, like this.
okay, let's see which one of these is correct. A, once you're done with the BFS tree, all of the options will be clear. So A, then you have B and E here on the next level. This is, let's say, first level, that this will be the second one. A, B, E, and no other vertices. Then B is connected to C, and E needs not to be counted. We don't have to count E again. So C, and then it's connected to F. That's it, right? So you'll have C and F here. And E is connected to, then you have to check E. First, you have to get done with every vertex in BFS. First, you explore this. And when you're done exploring this, then you move to this first vertex, explore this, then move to this next vertex, then explore this, then come to this other level, right? So E is directly connected to, F is already done, C is already done. So you just have J here. So with E, you just have J. Then with C, you have F is done. It's done, right? Yeah, all of these are done. So you're only left with D. You just have D here. And with F, you don't have anything further to add because D is already mentioned in our tree, and F is not connected to any other vertex which has not been mentioned so far. So this one ends here. Let's come to this cycle then. J.
And
J is
here we
directly connected
can
to.
stop here, right? Like we can see the options. Some of the options will disqualify. But till this
I
step,
don't think so. I
yes,
don't
ma'am.
think some of them will get this one. Let's see.
Like option B and C will disqualify
It's
because
okay. That depends on the options. You might have some options which might not get disqualified from here. Maybe you'll have all the options which will not. So it's better to just get done with the tree first and then come to the
okay.
options. That's a better way to do things. If something is getting disqualified from here, you obviously can rule out those options. But let's let's first get done with the tree. That's an easier approach, right? With
Yes, ma'am.
Directly connected to E. E is already mentioned in the tree. Then you have H, I, G directly connected to J, and K and P as well. So there are a lot of, it's connected to 4, right? So
5.
it's okay. G, H, I, P, and K. We have one more here. Okay, they're all on the same level. D is also on the same level as these ones. This is one level, then this is another level, then this is another level, then this is the next level. Then starting with G, G has nothing, H has nothing, I has nothing. So these three just end here. Then P has a lot to explore from here, and K has a lot too. So we have mentioned P first. So P, then you have directly connected Q, R, and T. So with P, you have Q, R, and T. And with K, you have O, L, N, and M. And S is still left, right? So S is under all of these. You can write it under. I'm writing it under this. And let's do one more thing. Although we have to just make the tree, so we cannot have cycles here. But because that we have already discussed this thing, BFS trees are not unique, right? So you can have more than one BFS tree. So let's just try to see all the possibilities. Okay. Some of the options might not even get ruled out from this thing because we have done it in a very particular way. Q is all, S is also under R, it's also under T. Then there are other vertices too that are under a lot of other options too. D is also under F. F was also under E. I'm drawing these ones for you to know that this is also, if you remove this one from here, then F can come under E as well. If you remove this one, then D can come under F as well. And S can come under any of these instead of Q. So for other possibilities of BFS trees. Now let's check the options. The first option is A, then E, then B, A, E, B. Then we have F, F, C, D. So F, C, and because we have to get done with the level first, and then we can move to the next level. So this level A, then B, E have to be next. Then C, F, and J have to be next in some order. In this order, or F, J, C, or F, C, J, in any order, but you need to have them before moving to next vertices, right? So if you have here F, C, and then D before J, and that's not right because before D you need to write J. So this option is incorrect because of this. There could be other mistakes as well, but we have figured out the mistake here. We don't have to check after this point. Then let's come to B option. B option says A first, then D, E on the next level, then C, F, J on the next level, then D, G, H, D, DGHITK. We want them on the same level. So DGHIK, we have DGHIK, and we have LO before P, which should not happen. We should have P first here, right? They're all on the same level. So P should come before O. You first get done with this level, which has GHITK. Then you can move to the vertices on the next level. And they're not doing that. The first mention O, which is a mistake. You should have P here. In fact, DGHIP, right? So only P is missing here. So your fault is here. DGHIK, this is the mistake. You should have P before O. So this is incorrect as well. Then let's move to the next option. It's AB. The next option is A, then B, E are fine. Then C, F, J, that's also fine. Then D, G, H, I, K, P, D, G, H, I, K, P, this D, G, H, I, K, and P. So this is also fine. If you see D, H, I, K, G, P, that's also fine. But you need to have all the vertices on the level covered first before moving to the next level. That's the idea. So this is also fine. KP, and then we have OLMN, OLMN, and QRT. We need to have OLMN, QRT before S, because S is on a different level than these 7. So these 7 are here first, and then S is at the end. That means this option is fine. C is fine. Then let's come to the last option. We have A, then we have EB. I already mentioned that the order does not matter. Either you write A or you write EB, BE, does not matter. So this is A, EB. Then you have JFC, JFC. That's also fine. Then next you have KPJ, KPG, HI, KPGHI, KPGHI, and D. So after these 3, CFJ, we want these 6, right? So we want D, G, H, I, P, K in some order. So we have them here. D, we have D here, then G, H, I, P, K. That means they're all in this. The ones on the same level are written together. That's the idea, right? Then the next level is this one. So we want Q, R, T, O, L, M, N. So from here you have L, M, N, O, and Q, R, T. They're written together, right? So it is A on the first level, then EB on the next one, then G, F, C on the next level, then KP, GH, ID on the next level, then LMNO, TRQ on the next level, and then S on the last level. Because this pattern is following here, that means this option is also correct. D is also correct. So we have these things here. Is this one clear to all? Can we move to the next question?
Yes, ma'am.
Okay. The next one is this. Give this one a try.
7.
I don't think 7 is possible here. Let's see. So we have to find the vertex cover. So for vertex cover, let's take, because these ones are connected to both. The outer ones, they're also connected to 3. Okay. So let's start from the alternating ones here. This is 1. Then because we don't need this one, this is already for this this edge, we already have this thing. So let's take this one. Then we don't need to take this one. And then we take this one. So these 3 are covering these ones. This edge is covered. Or wait. This edge is covered. This edge is covered. This is also covered. This is 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 covered. And this is covered. So far, all of these are covered. Then the left ones are these. So we want this vertex to be included in the vertex cover as well. Then okay, let's not take this one. For this one, we'll come to this edge later. Then let's take this one. Because there are no 3 edges here connected to this one, and none of them has been covered so far. So this one, then the same goes to this one. So now we have 1, 2, 3, 4, 5, 6. 6 vertices are already there in your vertex cover. And this covers these edges. This one, then this one. This covers this edge, and this edge. And we're still left with some edges, right? Which are the edges left? This one is left, this one is left. And this one is also left. This one's also left. Then let's have this one too. This is going to cover this. Oh, wait. You can't have, it's better to have this one. If instead of this, if I'll have this one, it's going to cover 2. This is covering, okay, this was also covering 2.
Yes, ma'am. So
That's the same thing then. Let's take this one. This is covering 2, this one and this one. And okay, we forgot, if you're taking this one, then this is
one
also
edge
covered,
is,
right?
yes, ma'am.
This is also covered. These are the edges covered so far, right? And what are left? This one is left. This one is also left. Only 2 edges are left. And no vertex is covering both of them, right? If we'll take this one, this edge will be left. If we'll take this one, this edge will be left. Sorry, this one. This edge will be left. And if we'll take this one will be left. So let's take, we'll have to take 2 now. Let's take this one and this one. So you will have this. Sorry. You will have this covered. And this covered too. So how many are these? This is 1, 2, 3, 4, 5, 6, 7, 8. Are we left with any more edges?
Ma'am, 9,
Okay,
it's not 8,
let's
it's 9, I guess.
2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, these are 9 in number. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right.
But ma'am, like,
Yeah, we will.
how do you make sure that the minimum is 9 here?
How do we make sure? You can't do it some other way, right? If I don't want to erase everything that I've done. Let's do this thing here. if you first when you are trying to figure out vertex cover, your first aim should be try to cover the vertices that have minimum edges from there, right? So if this has, so any vertex here does not have more than three edges. That's what I can see. This also has three edges. Some of them maybe only have two. No, they all have three, right?
Yes,
So
ma'am.
yeah, all of them have three. That's fine. So you start with, let's say you start with this one instead. Then you're only covering these three. You get to know only by trying to see which ones are getting covered. There's no hard and fast rule for it. So what I'm trying to say is we don't have a formula for it, or a hard or fast rule that this is, if you do this thing, then you can make sure that this is the minimum number, right? We don't have that rule. The one one thing that you should have in mind is that start with the vertex. That is, if you have something like this and it is connected to a lot of, it has a lot of edges going out from there, then you should choose this vertex for sure, right? Because it's covering a lot of edges. So try to target the vertices that cover most edges, like this one. All of them here are covering only three edges. So in this particular example, that point is of no use, but in most cases it is of use. So let's say you start with this one. Initially we started with these ones, right? The inner ones. Let's start with this one. Then there's no, or let's say you start with this, you have these three covered. You have these covered. Then if I start with this one, let's say if I start with this next, then you'll have this. Then let's say I'm taking this one next. Or if I write it, because all of these three are also not covered yet. So if I take this one, I have these vertices, these edges covered. Now you have to be careful. Why? So far we didn't have to be careful because all of these, when I started with this one, I had three edges to move. Then I started with this one, I had three edges to cover. With this one, I had three to cover. Now from this, right? That is what I was trying to say. The point was, when you see now, some of them have been covered, but from the remaining ones, from the ones that have not been covered so far, the vertices that you choose, the next one to be in your vertex cover, that vertex should be the one that's connected to most edges. So connected to most edges right now after this thing is this one. This vertex is connected to most. This is only connected to two. This is also connected to most, three, and this is also connected to most. These four are the options you have, right? This one, this one, this one, and this one. All the others are only covering two edges. So there's no point choosing them now, right?
Yes,
That won't be an optimal solution. That's why it's not ideal. So next up, you take up this one because it's now you have the maximum options from this vertex, three options. So this covers these edges. Then next up, you can choose out of, now there's no point choosing this one because again, you only have two choices from here, two edges it's covering. And this one, whereas this one and this one is covering three edges. So you should take up this one next. Or you can take this one also. But once you've chosen this one, now all of the ones that are left, look at the remaining ones, the remaining vertices that you have not chosen yet for your vertex cover. All of these are only connected to two. This is connected to two. By two, I mean the edges that are not covered yet. Out of those edges, it's only connected to two. Only connected to, this is only connected to one. No, this is also connected to two. This is only connected to one. This is also only connected to one. So if I write the number here, this is connected to just one. This is connected to just one. This is also left. This is also connected to just 1. This is connected to 2. This is also connected to just 1. These have been covered. This is also connected to just 1. This is connected to 2. This is also connected to 2. So out of these ones, now what are the ones that you should be choosing next? It should be this
Ma'am,
one. Right?
sorry
Yeah.
to interrupt. How it is connected to two, the last two?
Which one? Sorry.
How we are considering that this is connected with two? Is it because it looks similar, all three?
All three. Okay. Which are you talking about? Okay. What we're doing here is these edges are already covered, right? So forget about these edges for now because they're covered. So why would you choose a vertex which is connected to this one? Let's start with this vertex. Out of the remaining edges, what you're trying to collect here is you're trying to make a set of vertices, and you're trying to keep the vertices here that are connected to maximum number of edges. That's our aim, right? Because you want to cover every edge. So our idea is put the vertex in the set which is connected to maximum edges. That's the idea. So if you already have this vertex, these vertices, these are not even numbered, right? So I can't put them in set. So these ones, the marked ones, this one, this one, this one, this one, this one are already in your vertex cover. The red marked ones are in your vertex cover, right? They're already in the vertex cover. But we need more vertices in the vertex cover. These are not enough. 1, 2, 3, 4, 5 are not enough. We need more because this edge is left. This edge is also left. This edge is also left. So how should I choose those vertices? I should choose a vertex now, which is connected to most edges that are not covered yet, right? So this one is only connected to 1. This is the only edge that it's covering. If I'll put a, let's say, if I'll put a CCTV here, it will only cover this edge, right? Because this edge and this edge is also already covered. I don't need these two to be covered because they're already covered by these two cameras here, right? And this camera, if I'll install a camera here, it will only cover this edge. So this is going to cover
Ma'am,
one edge.
is it
Yeah.
color we do color coding kind of, we can do like that?
Color, what color?
We do like when you see the camera, we do the color code. We do apply one and then positive and then negative, two different color, and then again apply another color. Then two
Oh, that's
vertex not be similar kind of.
no, that's graph coloring problem. That is a different problem.
And
This
why
is
we are
vertex
not
cover problem.
this vertex, the left, the between in middle, we are not considering that
Are you
this.
talking about these?
Yeah,
Or what are you talking about?
yes, sir. Left to right, this line, the middle one.
This
We are
one,
not.
there are
No,
only two types of vertices. On the outer one, the outer ones and the inner ones. Which vertices are you talking about?
the outer one is going 1 to 1. The in the yes, correct. Yes.
This one. Out of these, they've already chosen these ones. This is chosen, this is chosen, this is chosen. Now, out of the remaining ones, the remaining outer ones, that's what I'm saying. This particular vertex is
Yes,
only
ma'am.
covering
Yes.
one edge. So if I install a CCTV here, it's only going to cover this edge. But if I install, which ones are left? If I install one here, this is going to cover 2, right? A CCTV here will cover 2 edges. A CCTV here is only going to cover 1. Let's first put the ones here.
But the
Yeah,
question is minimum vertex cover for G.
that's the algorithm to find. That's the easiest way to find. If you will do it randomly, let's choose this one, let's choose this one, then there's no point, no? Then you wouldn't be able to find minimum. You might, if you will just randomly go about vertices, you might find the answer to be 10 or maybe 12. To ensure that it's someone asked, how do we know that it's the minimum vertex cover? I'm answering that question here. How do we ensure that this is the minimum vertex cover?
Okay, ma'am.
You have to find the optimal solution, right? Optimal here means minimum number of vertices that cover all the edges. That will be your optimal solution. if that's your aim, then you should be choosing the vertex which is connected to most number of edges. That's the idea. That's the sole idea. That's it. So you keep picking the vertices that are connected to, let's say if you have a graph like this. So my first instinct should be, if I have to find a vertex cover for this graph, my first instinct should be choose this vertex because it is connected to one, or let's say
The top right you
for
can
to,
choose.
to make my point more clear, let me just do one more thing. Let's take an easy graph. Let's say I have this thing. Now, if I have to find a vertex cover, the first vertex that should come to my mind to put in, let's say this is V1, this is V2, this is V3, this is V4, and this is V5. The first vertex that will come to anyone's mind would be choose this vertex because it's connected, it is covering the most number of edges, right? This one, this one, this one, this one. So first instinct would be put V1 in your vertex cover first. Then the next one will be, now this edge is covered, this is covered, this is covered, this is covered, this is covered. So there is no point. Now the remaining ones are this one, this one, this one. Which out of these is covering the maximum number of edges? So your next option should be either V4 or V3, right? Because V3 is covering 2 edges out of the remaining ones. These 4 are already covered. The remaining ones are these. This is left, and this is left to cover. So out of these 3, V3 is covering these 2, V4 is covering these 2, V5 is only covering 1. V2 is, there's no point putting V5 next. So I should put either V3 or V4 next. Now, if I have V3 next, these 2 are covered. That means the next one I can choose from V4 to V5. V4 or V5, anyone. You can choose V4 or you can choose V1, V3 and V5. That's also fine, right? And you don't even need the cover. You just need the number of elements in the cover. And the number of elements are going to be 3 in this particular example that we've discussed. So the same thing we are doing here. We're trying to cover the vertices that are connected to most number of edges first, to make sure that we get the right vertex cover. That what we're actually finding is the vertex cover. Right? So next you should take this one, either this one or this one or this one. So let's take this one. And by the way, this is just one. Why have I written 2 here? This is covering just 1, right? 1. Yeah, only 1. So you should be picking from these 2, either this one or this one. So I'm choosing this one next. If I choose this one, now these 2 are covered. Now look at the minimum. This has nothing to cover now. This is 0. This is also 0. Nothing to cover from here. Nothing to cover from here. Now we have this as 1. This is still 1. This is still 1. This still covers just one edge. This still covers 2 edges. This still covers just 1 edge. These might change, by the way. These numbers that we've written can change, right? This is still covering 1 edge. So our next should be this one, this vertex. So let's choose this one next. So you will have this edge covered, this edge covered. And now we're left with, now this number changes. This vertex has nothing to cover. So this gets removed. This still has this edge to cover. This still has this edge to cover. And this has this edge to cover. And how many edges? Now let's choose this one. Because all of these are just 1, 1, 1. So you can randomly choose any of these. Let's say I'm choosing this one. If I choose this one, now this edge is covered. This vertex has nothing to cover. Leave this. Now you're only left with this one. So the next one you should be choosing is this one. This one. So that you can cover this edge. Now this was the only remaining edge and this also got covered. Now you just count the numbers. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the total numbers here are for your vertex cover number of elements in your vertex cover would be 9. Is this fine?
Yes, ma'am. It's clear.
Okay. Now let's do this question. This is the class. So let's one. Even if you've been asked to find the minimum cost of the, then you can follow any algorithm, no matter what your question says. Even if it says find using Kruskal's algorithm, you can use Prim's, because you just have to write the answer. So let's start. Let's question using Kruskal's, because that's comparatively simpler algorithm. So first one will be this. So let's start from this one. This is the minimum edge, minimum weight edge. So this one we take. Then next up we take one.
A,
Then after
B.
one we have this one to cover this edge. Next one. Then after 1, 2 we have 3, right? So but we cannot take this one because it's forming a cycle and we wanted 3. So we can't take this one. We're not taking this.
B
Then
to
after
C.
3 you have 4. Take this one. And after this you have 5. This one. Then after 5 you have 6. Take this one. Then you have 7, but 7 is forming a cycle. So don't take this one. Move to the next number, 8. Choose this one. Then this is again forming a cycle. 9, 1. Next is this. Next minimum one is this, but it's forming a cycle. So don't take this one. And this is again forming a cycle, which means your tree has been covered. You have found your tree, minimum cost spanning tree. So this is the required tree. And you can check it, confirm it by checking whether all the vertices have been covered or not. So this all have been covered. That's why this is your minimum. The red marked one is your minimum cost
If I
spanning tree.
start from F, then it will be wrong. I will get the wrong answer if I start from F, because I
If
can
you're using Kruskal's algorithm, then start with the minimum one. If you're using Prim's algorithm, you can use any vertex. In Prim's algorithm, it does not matter what you choose as the first vertex, but in Kruskal's algorithm, it does matter.
If
You
it
have to
is
start
not
with the
mentioned, because here it is not mentioned that which algorithm we need to use.
That's why we use the simpler one. Kruskal's algorithm is comparatively simpler compared to Prim's algorithm. You just have to arrange these edges in ascending order and then choose them in such a manner that there's no cycle. So it's just easier. If you've not, that's my suggestion. If you want to do it Prim's way, we can do that too.
Ma'am,
But we
for
already
this
have a dedicated
question,
question. Yeah.
so what I'm asking is, for this question, the spanning tree, I mean, this is the only spanning tree possible, right? Because we have like unique
Yeah, they're all
weights.
different numbers. Yeah. All different weights. So
Okay.
this is the unique one possible. 1, 2, 3. 4 is also there. 3 is not there, right? 1, 2, 4, 5. What's the total weight? Let's just count it without writing.
26.
It's 1, 3. Okay, let's say 1, 7, 12, 20, 26. Right. So it's 26. If this, I hope this one is clear. The Prim's algorithm, Kruskal's algorithm is probably the simplest part of graph theory. So let's move to the next one. In this one, it's been mentioned that you have to use Prim's algorithm, and because you have to write the order, that's why it does matter that you do this question using Prim's algorithm only. So don't do it using Kruskal's algorithm. You'll get a different answer, and that will be incorrect because you have to find the order here. So the only type of questions where you can use the the algorithm that you want are the ones where only minimum cost has been asked. If you've only been asked to find the minimum cost of a spanning tree, then you can use whichever algorithm you want. It doesn't matter what's mentioned in the question, use whatever you want, but only when you have to find minimum cost. Don't do it in any type of question. Like in this question, you have to use Prim's algorithm. So let's first try to make the graph of this one. So this is V1, V2, and this is also V1, V2, V3. So we have V1, V2, V3, V4, V5, V6, and V7. So V1, we have an edge from V1 to V2, which is 24. Then we have one from V1 to V3, V4. Let me just write this down. It will be V7, V3, V4, V5, V6, V7. Eight. V1, V2, V3, V4, 5, 6, and 7. So from V1, we have till V2, we have 24, then 36, and 28. With V5, we have, let's make V5 here. 36, then V7, 28. Then next we have from V2 to V1, it's 20, that's already done. Then V4, 32. V2 to V4, it's 32. Let's make this one here. Then that's it. And then from V3 to V6, it's 4. V3 to V6, it's 4. And V3 to V7, it's 12. Then from V4 to V2, I think that's already done. And from V4 to V5, 8. That's it. V4 to V5, we have 8.
Ma'am, some of the weight says 0
This
here,
one
right?
is 32. Where?
So,
With sum of weights.
like what is the meaning of this 0 in the matrix?
You only have, when you have 0 here, let's say you have, that means there is, when you have 0 here, that means there's no edge, right?
No edge. Okay,
It-
so this, I mean, this Prim's algorithm is valid for
don't have-
negative weight graphs, right?
Prim's algorithm, you don't have the concept of negative and all in minimum cost spanning trees. We don't have negative
Okay,
weights
okay.
there. And when you have, this is just the adjacency matrix. So whenever you have a 0 in adjacency matrix, like we used to have 0 and 1, when we had no weights, we had 0 and 1 entries, right? So 0 meant no edges, no edge from this vertex to this vertex, and 1 meant there is an edge from this vertex to this vertex, right? So we were we were on the 4th vertex. Then 5th one, we have no other edges. For 6th one, we have from V6 to V7, 20. V6 plus V7. This is 20. Then from V7, that's it, right? So this is your tree. Sorry, this is your graph. I hope we have not missed any weight. Let's just 1, 2, 3, 4, 5, 6, 7, 8. Let's just check here. How many entries are non-zero here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. Here we have 16 non-zero entries, and because it's a undirected graph, so only eight edges will be there. Okay. So this is correct graphically. Now let's come to, if you start now in Prim's algorithm, you have a vertex to start from, right? We have discussed this in summary, and your vertex to start from is V1.
Half of number, right, ma'am? This
What?
the number is there is a repeated number, right?
Yeah, in undirected graphs, your undirected graphs are like this, right? If you have an entry from V1 to V2, represents the same edge. That's why here you will see 16 entries, but there are only 8 edges. It's an undirected graph, that's why. Is that what you were asking?
Yes, ma'am.
Okay.
How to check that
Anyway.
my graph is correct?
You will check your graph is correct. First, you count the number of edges here. Here I counted, there are 8 number of edges in this graph. And here you will see 16 non-zero entries. So your non-zero entries in this one are 16. And because we already know that it's an undirected graph, so in an undirected graph, if you see 16 non-zero entries, that's what I was discussing here. Let's say you have a 3x3 matrix, right? So if you see, if this entry is non-zero, what happens in an undirected graph? This means you have an edge from V1 to V2, right? There's an edge from V1 to V2, and because it's an undirected graph, if there's an edge from V1 to V2, it's counted as an edge from V2 to V1 as well. So you will see if you have 3 here, you will have 3 here as well. That's what happens in. So that means if you see one non-zero entry here, one non-zero entry, if you see 2 non-zero entries in your, everything else is 0. If this is your graph, then that means in this non-zero entries are true, 2, right? These 2 are non-zero. This is 3 and this is also 3. But the number of edges here is just 1. So for an undirected graph, the number of edges is equal to the number of non-zero entries divided by 2. So in your adjacency matrix, if you have 2 number of non-zero entries divided by 2, this is the number of edges that you have in your graph. That's how you check it. Is that okay? Okay. So we've made the graph correctly. Now let's find the order starting from V1. So V1 is the first one, obviously. You start from here. Then the unlocked ones would be these ones. This gets unlocked, this gets unlocked, this gets unlocked, right? And you choose the minimum from these. So this will be the next vertex. This is covered and the next vertex is this. So your next vertex is V2. Then from V2, this gets unlocked. That's it. And you have to choose the minimum from, 1 second. We are 32 here, right? 32. So this gets unlocked and you have to choose the minimum from the unlocked ones. So this is 1, 2, and 3. You have to choose the minimum from these three. It's 28, 36, and 32. So the minimum one is this. So next is this one. So your next one should be V7. And so far, there's only one option which matches this order, which is this one. V1, V2, and V7. So only this matches the order that we have found so far. So you don't have to do the entire thing. You can just take this one. But if you really want to find the entire order, then how do you take the next vertex? You have done till V7. So this gets unlocked and this gets unlocked. Now you have to choose the minimum from these, the unlocked ones. So you have to choose the minimum from this one, this one, this one, and this one. So the minimum is 12. The next one that gets unlocked is V3. So we'll have V3 next. Then from V3, this gets unlocked. So out of the unlocked ones that have not been covered so far, so it's this one, and this one. You have to choose the minimum. So the minimum is this 4, right? So this goes next. V6 goes next. And then again, these ones are the unlocked ones because from V6, nothing gets unlocked. This was already unlocked. So you have the same edges 20, 36, and 32. So you have to choose the minimum from these ones. There's no point choosing this one because V7 has already been covered. So you have to choose the minimum from these two. So this is 32 and 36. So the minimum is this. So the next one in the order should be V4. And then this gets unlocked. Now all the edges are unlocked and nothing is left, by the way. Only these two are left to choose the minimum from. So the minimum is this one. The next that gets unlocked, there's only one left, right? Only V5 is left. That gets unlocked next. So this is the order V1, V2, V7, V3, this order, which is the same as this one. And you could find this out only by doing till here because only this option matches this order. Is this fine? Can we move to the next question?
Yes, ma'am.
Okay. This one is the next question. You have to use matrix multiplication to find a square from a1. This is a1, this is a square, and then you have to find the value of, so let's say this is a square. You have to find the value of 2 alpha beta. So to find the value of this expression, you need to find the value of this entry alpha and this entry beta. And how do you get this entry is, if this matrix is, if I'm calling this matrix M, then this entry is M12, which means first row multiplied with second column, right? So this row multiplied with this column.
0.
So you get, yeah, because this entire column is just 0, so you're going to get 0. That means your alpha will be 0. And for beta, for this entry, you have to multiply. This is third row. This is, if the matrix is M, then B should be equal to 3 and 1, 2, 3, 4, 5. So it's 3, 5. And the 3/5 entry, that means third row, fifth column. So it's this one. Third row, fifth column. Multiply this with this, this with this. You have to, you know how to multiply, right? Multiply in matrices. So this will be 0, 0, 0, 1, and 0, right? So this is, when you will multiply, you will get this thing, 0 plus 0 plus 0 plus 1 plus 0. This is just going to give you 1. And so this beta entry will be equal to 1. And you have to find 2 alpha plus beta, which is just 1, right? Beta is 1, alpha is 0, so this should be 1. Is this okay?
Yes,
If you
ma'am.
want to recall the multiplication and addition in these matrix multiplication, how do you multiply and add entries? So if you have 0 multiplied with 0, this is, in multiplication, it's just usual multiplication. 1, 0 is also 0 and 1, 1 is 1. But in addition, there's a change. This is 0. This is 1. This is 1. Or actually, and this is also 1. So all in all, if you see, if you see while multiplying, if you see 1 plus 1 plus 1, something like this just means 1. Yeah, in matrix multiplication, if you see something like this. So this expression, the value of this expression is just 1.
Ma'am,
Yep.
ma'am, the values will always be 0 and 1, or it can be other constants.
You only when we multiply stuff, why we multiply is what multiplication means is if you have a, it's about the paths, right? If you have a, this means if you have a 0 here, that means, and a 1 here, that means you have from vertex 1 to vertex 2, there's an edge. Now, what does this mean? If in a square you have 0 here and 1 here, this means that you have a path from V1 to V2, which involves other vertex 2, right? This is what it means. That means it has a path from V1 to V2. If you have 1 here in a square, if a 1/2th entry of a square is 1, that means there is one vertex between V1 and V2, and using that vertex, you can connect V1 and V2. So when you this is all about having a path. A square is about having a path of order 2 from V1 to V2, or from, if you have a square ij, this means having a path of length 2. Length 2 means this is a path of length 2, right? This is a path of length 3.
Ma'am, is
So this
this
means
exactly length 2 or like at most length 2?
this is exactly 2. This means
Okay.
exactly 2. Do you have a path of length 2 from I to j? If you have it, you write 1. If you don't have it, you write 0.
If we have a direct path,
If you have
then
a,
from I to J, let's say, we have a direct path, but not a path of length 2. Then in that case, will it be 1 or 0?
it should be 0. It will be 0.
Acha, acha.
This
Okay,
is
okay.
about path of length 2. A cube is about path of length 3. So that's the
Okay.
idea here. So you can only have 0 and 1. So someone was talking about having weights here.
Ma'am, can you repeat the line how beta get 1 multiply?
Which line?
Ma'am, after multiplying 0, it's like how to multiply, ma'am?
Multiply, let's say, okay. Let's say you have this thing, you have a matrix here. You have 0, 0, 0, 1, 0, 1, 1, 0. Let's say you have this thing. And then you have to multiply, this is A, and you have to find A square. So this will be 0, 0, 0, 1, 0, 1, and 1, 0, 0. So first entry will be just 0 because all the entries are 0 here. Let's say you have to find A square and 2, 1 entry of this. 2, 1 entry means second row of this and first column of this, right? So this will be 1 times 0. This and this. So this is 1, 0, this is 0, 1, and this will be 1, 1. So we know 1 times 0 is just 0. 0 times 1 is just 0. That's what I've written here, this entire thing. And 1 times 1 is 1, right? So this will just be 1. Now let's say if instead here you had 1, if you had this thing, then you'll have 1 here. Then your answer would just be 1. It's still 1 because 1 plus 1 is 1, right? Here. Is this okay?
So beta get 1, right?
Sorry, what?
I'm talking about beta, ma'am.
Yeah, beta here is 1. It's 1 because for beta you have to multiply this row with this column. So you will get 1. Beta will be 1. Beta is the 3/5 entry of this matrix, right? So you have to multiply third row and fifth column.
Okay, got it.
Does anyone have any other doubt in this?
No, ma'am.
Okay. Can we move to the next question?
Yes, ma'am.
This is the next question. You have to use Dijkstra's algorithm here. So your Dijkstra's algorithm is you have to start starting node is always given to you, and here it's given to be A. You have to start from here, and you have to find you have to apply the Dijkstra's algorithm next. So how do we apply the Dijkstra's algorithm? This one, obviously we do it using a table, but we don't actually need a table here. If you want to make a table, you can still make a table A, B, C, D, E, F. But that's not needed because this one is just simpler. You don't need a table here. Then you will write the distances here. So from A to A, it's just 0. Then from A to B, it's 1. B, A to C, it's 3. And then 0, 0. Others are at distance infinity, right? So they'll be infinity, infinity, infinity. Then you will choose the minimum. So this one. So you have to find the order, right? So this one gets covered next. B gets covered next after A. A is obviously the starting point. The next one that gets covered is, we've already talked about this, right? That in our summary lectures, that the minimum one, you choose the minimum and then you fix it. That means after A, the next vertex to be chosen is B. B gets fixed next. That order you have to find. You have to find the order in which your vertices get fixed here. So A is there, then B gets fixed. So, and then from B, you have to find the immediate ones, right? This one, and this one. So it will be 1 here. You'll have 1. The distance till B is now 1. The distance till A is 0. From A to A, it's 0. From A to B, it's fixed 1. Now from B to E, it will be 6 plus this 1 already there. So it will be 7. So this distance till E will be 7. Then till E, till D, it will be 1 plus 3, 4. Then till C, it will be 1 plus 2, 3. And this one has been fixed already, right? So you can fix it here. Wherever you want, this does not matter. So this has been fixed. So now and this is still at distance infinity. This is 0. So you have to choose the next minimum. The next minimum is C. So the next minimum that you choose is this. C. So first was A, then B, then C. Next minimum. Then you have to find the distance till C. From A to C, the distance is 3. It has been fixed. Now from C, you will have 3. Here you have distance 3. Here you have distance 1. Here you have distance 0. 3, you will add 4 here. So it will be 7. And you only update when it's a better distance, right? When it's a shorter distance. So you don't update it. It remains 4. Then that's it. You could only update D because only D is directly connected to C. And you will not update it because you have a better option here. 4 is smaller than 7, so no need to update. You keep it as 4, 7, infinity, 3, 1, 0. So if you choose the minimum from these three. So the next minimum is going to be 4. So the next vertex to be chosen is D. Then from D, so it's going like this. From D, you have directly connected ones. B is already done, right? B is already done, so you don't need to
Ma'am, from
check
B,
this one. Yeah.
B we can go to D by this 3 path, right? That would cost less.
This one,
Yes, ma'am.
how is it? B is already, the distance till B, if you will take this route, will be 1. Now,
That
if you
is
take this
1.
one, it's 3
And
already. And then there'll be more. 1, 2, 4, and 3.
no,
It's
I
a
am
lot,
saying
right?
that A to B, then B to D. Can we
This
go
one.
like that? B to C will be there. And from B to D, that would cost us 4. 3 plus 1.
That's all right. You don't have to, in fact, okay, you're talking about the path, that this path is going to be shorter, right?
Yes, ma'am. Yes, ma'am.
That's fine, but we just need to know the order, and this is order has been asked, right? So this is going to be
Okay.
the order, even when you take this one. And you're right, you should be taking this one instead of taking this path. This is the path. But from this whole thing, you'll get this order. So we're done till D, right? And then after D, the distance is, we change the distance. So till D, we have distance. How much is the distance till D?
4.
Okay. And it does not even, okay, till distance till D is 4, right? So it's 4 here. Then from 4, this distance till F will be 4 plus 1, 5. This gets updated. And then from this 4, from D to E, it will be 4 plus 4, 8. And you already have 7, a better option here. So just keep it 7. And you have to choose the minimum from these two this time. So the minimum is this one. So the next in line is F. And the obviously know the next one is going to be the one that's left, which is that okay? Options A, B, C, D, F, E. That's the correct answer. So if you've been asked to find the order, this is what you have to do.
The
Is that
answer,
okay?
the number will be, the value will be 11, is correct?
Value, you don't need the value here.
Okay.
Value. Okay,
I
Dijkstra,
decided according to the weightage of the vertex, and I also got the same because I'm always confused with this to choose.
if you're doing it manually using just this graph, and if you're not, this table is also constructed using the weights only. This is just a more systematic way. And this graph is very simple. What's happening here is you can clearly see that if I go from this path, then the next that I should take is this one. Because this is also 3, this is also 3. So it doesn't matter. If you go from A to C using this path, that's also same. If you directly go from A to C, that also gives you the same value 3. Then next you should be taking up is this one. If you take this path, this is a longer path. If you take this one, this is a shorter one, 1 plus 3. So this is what you should be taking next. This is 1 plus 3, 4. This is 1 plus 6. That's what you're talking about, right? That you've done it directly from the graph without using this
Yes,
table,
ma'am.
is it?
Yes.
But this is not something that you should stick to, because there might be complicated graphs in exam and you might not be able to do it using just this way. This is not a short way that will give you the correct answer all the time. You might end up making mistakes doing this thing. There are always chances of slip ups in this way. That's why we have an algorithm to perform this thing, right? If you have a doubt in the algorithm, I can explain that.
Yes, ma'am.
But I suggest,
Where
yeah,
that day also I was confused, and to fix this, how you are fixing this, the matrix?
this matrix is just distances. This is not even a matrix or anything. It's just distances written here. So what we're doing here is we start with 0, 1. We start with A. You're doing the same thing. Even if you do it manually, you will do the same thing. What you will do is you start from A and then you will choose the minimum one. Minimum of 1 and 3. That's how you decide that next step should be B, right? How did you decide that next step should be B? By
Because
looking at
it
the
is
minimum
of
of 1 and 3, right?
yes, yes.
That's what we do here in this algorithm. You choose the minimum, you write the distances. So this one is at distance 1, 3, and all the others are at distance infinity. These ones are at distance infinity, right? And then you choose the minimum from here. And that's how you fix the distance. When do we fix the distance? When we find the minimum. So if out of this row, the minimum is 1, this column, the minimum is 1, you should fix the distance till B as 1. Now and that's what you were doing manually too, right? You chose this path and you said the distance for B is fixed now, it's 1, right?
Okay, we need to fix that what is lesser than the I have the number.
Yeah. Okay, I'm not sure what you're asking, but let's just let me just quickly take you through this algorithm, and then you can ask if there are other doubts. So now you are at B. the distance from A to A is 0, it's fixed. And that's exactly what you do in the table. So you mark 0 as fixed, that means the distance you started from A. The distance from A to A is 0, the distance from A to A. B, minimum distance from A to B is, obviously the distance could be taken as 3 plus 2, 5 as well, but that's not the minimum distance. So what our aim is to find the minimum distance. So the minimum distance from A to B is 1, and we fix that distance here 1. Then this distance is already 1, and then you find the other one. So the directly connected ones to B here are these ones. So it's 2, 3, and 6. And then you add 1 to each of them because the distance till B is 1. And if you will go to C, the total distance will be 1 from here and 2 from here, right? So the total distance till C will be 3. The total distance here will be 7. The distance here will be 4. And then you choose the minimum. That's what you're doing manually, right? We're doing the same thing in the table. That's it.
Yes, we do the same.
We've written 3, 4, 7 here, and we choose the minimum then. And that's how we decide that, okay, you choose the minimum from here. This is the minimum. So I'll go here. That's what we've done here. Choose the vertex with the minimum distance. So choose C next.
So once we reach F, so at F, we have covered like 4 plus 1, 5. So at F, we are 5. So if we go to from F to E, so 5 plus 3 would be 8. So rather than
Yeah.
going by there, can we direct come from B to E?
That's what you have to do. If you have to find the minimum distance till E, it should not be 8, it should be 7. Because
Yeah.
7 is, that's why we didn't update 7, right? But we have not been asked the distance. The good part here in this question is we don't need the distances, we just need the order. That's it.
This is MSQ questions, right now?
Yeah.
So
Not
what,
MSQ, it's MCQ.
I mean, yeah.
Yeah.
So where is the options?
I already told you, I have not taken the screenshot of the options here. But how does it matter? You anyway have to find this thing. Okay. So that's it, I guess. I don't have any more questions. If you have any doubts, we can discuss those doubts here. Yeah.
Question number, let me tell you.
Ma'am, will there be any more revision session, or this is the only one?
You will have a mock session with the TAs, and please practice one kind of question that I've forgotten here are those ones, the Riemann sum ones. Please practice those questions because we're already running out of already half hour past the usual time. So I'm not doing that question here, but you have questions from Riemann sum, and please practice those questions, the Riemann sum ones.
Okay.
Yeah, in our previous session, we actually were asking about the weightage for the end term. We were told that we will get an intimation about that, about the syllabus weightage. Whether now it's going to be more weightage given to 8 to 12, or how it's going to be allocated.
Just 1 second.
Question number 3, graded assignment 11.
Graded assignment which?
11 week.
Okay, let's just first discuss about the weightage part.
Yes, ma'am. Feeling very scared.
And ma'am, like one more thing, ma'am, the TA session, the mock discussion session will be recorded or not?
I mean, quiz 2, what we understand, what we learned, it did not come in exam.
For
We practiced for this practical, and it came theory questions only.
just 1 second, what?
In quiz 2, we
Yeah.
practiced a lot practical questions. solving questions, and in exam it came only theory.
There were questions which needed to be solved. I don't think it was any theory. Your syllabus has nothing nothing of theory from week 5 to 8, I guess. Do we have any theory from week 5 to 8? Those must be conceptual questions. We don't have any theory there. So graph theory holds a lot of weightage. It's around 40%. So please practice those questions from graph theory. 35 to 40% is from graph theory. And yeah. Question now.
And the other thing also which I realized that like when we have this the quiz 1 and quiz 2, we had 2 hours of time for the subject, but now for the intern there is only one and
Can't
a half
hear you.
hours of time. Can you hear me now?
Yeah.
Ma'am, can you hear me?
Yes. Yeah.
Yeah. What my this thing I see the hall ticket is released today, and there it is mentioned for the interim exam the time for the subject is 1.5 hours, whereas in quiz 1 and quiz 2 we had 2 hours of time for the exam. So I'm wondering how this interim being a full subject from 1 to 12, given that 1.5 hours time, will we be able to solve this?
Ma'am, I did not receive my hall ticket yet.
You
What is
won't
the
be able to
problem?
solve it. It's been designed that way.
Okay.
But quiz
Mm.
1, quiz 2
What?
was for 1
Ma'am,
hour
I did
only.
not received my hall ticket yet.
Did you check with your
Yeah.
dashboard?
I checked.
Just refresh your
You'll
dashboard.
have to contact the.
Where did you check your in your dashboard?
In the dashboard, the hall ticket. On the left hand side, you have the panel number, right? The
Yes.
hall ticket.
Yeah.
There
You
you
have
can.
to.
It's still written there. The hall ticket will be uploaded here only.
So maybe it takes some time. But I think tonight or tomorrow morning you'll be seeing that. If not.
Okay, I checked this question. It's from the just 1 second. Yeah. This is, you just have to find the matrices A in this question. Someone had a doubt in this question. Just find the matrix A for each of the graphs, and then you can find out A square and let.
If you can solve so
Just match it with what's given as A. Time for me to write. Firstly, for me to. Okay.
Ma'am, what about weightage?
Just
You
1
said
second.
only about the graph theory.
Yeah, the rest of the part is from week 1 to 9. So from week 1 to 9, you have 60% something in your exam. The other weeks have equal weightage, almost equal, and not, if not equal, they're almost equal. Because it's been a lot of time, this question, someone has a doubt in this question, it's going to take time for me to construct A for each of them and then find A square. So what you can do is there are obviously tricks to this question. You can ask this as doubt in one of your TA sessions. You do have TA sessions, right? Today is Tuesday, so you're going to have TA sessions coming up. You can raise this question there. Okay, so we'll end this session here. Yes.
These end-term exam questions are made by instructors or professors?
Sorry, what?
I mean, these end-term exam questions are made by instructors or professors?
You don't need to know that.
That
All you need to know is that from whatever you've been taught and whatever you've learned, you should be able to solve those questions.
Thank you, ma'am. Good
Okay.
night.
So thank you. Thank you for joining.